Out on the road, Wally, when I press the brake pedal, the car pulls to the right.
It does?
And it sounded like the right front brake squeaked, too. What do you figure is wrong?
Well, you'll never find out by looking at the outside, George.
Right. The answer's inside, my boy. Wally's got to pull those wheels before he knows anything.
Yes, but what could be wrong?
Before you can diagnose brake trouble, George, you've got to know how all parts of the brake work. You understand the fundamentals of the hydraulic system already. So, let's look at the fundamentals of the mechanical parts and see how friction and wear characteristics come into the picture and how the lining, shoes, and drums operate. Now, you remember we said that each brake shoe is connected by a push rod to a wheel cylinder at one end and hinged around the anchor bolt at the other end. When the driver pushes down on the brake pedal, he pumps fluid out of the master cylinder to the wheel cylinders and pushes the brake shoes out against the drum. Shoes are fitted with coil springs called brake shoe return springs. They pull the shoes away from the drum when the brakes are released. Each shoe is held in place by a flat steel spring riveted to the support plate. It's called the guide spring. It holds the shoe square with the drum. Under this guide spring, there is a brake adjusting cam that regulates the clearance between the shoe and the drum.
Now, you know the brake shoe should be set so it contacts the drum evenly all along the lining surface.
Right, Tech. That's why the clearance between the shoe and the drum must be right from the toe end to the heel end. On this car, the clearance should be 0.06 of an inch at both ends, so the brakes will take hold evenly and the car won't pull to one side.
Also, the shoes have to fit square with the drums, so the entire width of the lining surface contacts the drum evenly.
Yes, George, a good part of your mechanical trouble with brakes happens when the shoe and the drum aren't lined up properly, either lengthwise or across the width. Now, George, you probably know that it's friction between the brake lining and the drum that overcomes the momentum of the car and brings it to a stop. This means that the lining must have good wearing qualities and even friction characteristics.
And what does that mean?
Well, George, a lining must resist temperature changes and dampness, as well as being able to get rid of heat rapidly.
Yes, and really good linings are designed so they won't cause scoring or excessive wear on the drum.
And another thing, George, you don't want to be taken in by claims that certain linings will stop squeaks because they're specially designed for that purpose. Extremely soft lining will wear out too fast.
In other words, since you can't tell a good lining by looking at it, stick with Mopar service lining and be safe.
Right. Mopar surface linings have been developed by Chrysler engineers as the most satisfactory for our brakes to give you good braking action with long wear. But even the right lining isn't the whole story, George. Shoes have to be adjusted to the right clearance at both ends to give long lining wear and freedom from squeak. You see, it's often the terrific pressure on the small area of lining due to poor adjustment that causes vibration and noise.
Can anything else cause brake trouble beside a bad fit between the drum and the shoe?
You bet. Didn't you ever hear of getting grease on the lining?
That's right, George. Oil, grease, or brake fluid on a lining is bad. If there's a small amount on the lining, the brakes will grab.
So if it happens to be a right front lining that has grease on it, the car will pull to the right when you put on the brakes.
Why can't you just wipe the grease off the lining and let it dry out?
It's not that easy, George. When grease soaks into the lining, the heat keeps bringing the grease to the surface, and that means a reline job. So when handling linings, be sure to keep your hands clean. But if you do get grease or brake fluid on by accident, wipe it off right away before it soaks in. Even a small amount can affect brake operation.
And don't use cleaning solvent or gasoline to wipe grease off the linings, George. It thins out the grease and lets it soak in deeper. And another thing, put a block under the brake pedal before you start, just so the pedal can't get pushed accidentally and spray fluid all over everything.
You haven't said anything about water yet. Doesn't water on the linings cause grabbing, too?
Water causes loss of brakes because it acts as a temporary lubricant. But if only one wheel gets wet, the car may seem to pull toward the dry wheel. However, after the brakes have been used a few times, the friction dries up the water, and the brakes are okay again. Now, George, there are other reasons why brakes squeak, and one of these causes is dirt. Road dust and grit that get into the brakes may eventually work into the lining. These dirt particles scratch the drum, so the brakes make noise.
Another way the drum gets scored is by dirt piling up in the rivet holes and hardening there. When the lining wears down from normal use, this hardened dirt scores the drum.
Well, George, come on and help me fix up this job, and I'll give you some tips on other conditions. Now, here's our problem. The owner of this car complains of his brakes pulling to the right and squeaking. I pulled the wheels and inspected the hydraulic system, and it checks out okay. The next step is to inspect the linings and brake drums for signs of wear. See how this right front lining is worn, George?
Yes, Wally. These linings are worn down almost to the rivet heads at the toe end, but that's funny. There's almost no wear at all on the heels of the shoes.
Yes, and look, George, on the left front wheel, the shoes are worn down evenly all along the surface.
But wait a second. If the shoes on the left wheel are making more even contact with the drum than the shoes on the right wheel, how come the car pulls to the right?
Well, here's the answer. The shoes on the right wheel are out of adjustment, so only the toe end of the linings touches the drum.
Yes, Tech, and the shoes on the left wheel are contacting the drum evenly over the entire lining area, so the braking is even over the whole surface. That means the shoes on the right wheel pull into the drum a lot harder than the left wheel shoes, and so the car pulls to the right. Here's why that happens. When there's less clearance at the toe end of a shoe than at the heel end, the toe end meets the drum first. This causes a quick concentration of friction at the toe end, making the braking effort greater on that wheel. The toe end is pulled into the drum harder by the rotation of the drum, and may cause the rest of the shoe to make noise while trying to make contact.
And remember, fellows, any time a small area of lining does all the work, the wear will be greater there, too.
Now, this right wheel lining is worn so badly that we'll have to replace it. And, of course, that means we'll have to reline the shoes on the left wheel, too.
How come, Wally?
Well, you see, if the linings on one side of the car are new and the others are worn, the linings may take hold unevenly due to change in the old lining's friction characteristics, and the car will pull to one side. Well, that about takes care of wear on the ends of the shoes, doesn't it?
You mean there are other kinds of wear?
Hey, you bet. But we're about at the end of this record, too, so let's turn it over.
Take a lining like this with all the wear at the inside edge. This happens when there's too little clearance between the cam pin and the web of the shoe. The pressure of the guide pin forces the shoe outward, so that the inner edge of the lining hits the drum first and causes squeaking.
You notice, George, that in this case, the cam pin holds the shoe out.
And that means noise and uneven lining wear, because the entire braking force of the drum is concentrated on the edge of the lining instead of on the whole surface. But if there's too much clearance between the cam pin and the shoe web, the shoe will be twisted the other way by the guide spring, and the outside edge of the lining will hit the drum first. In this case, the pressure against the drum straightens up the shoe right away. Although not serious, it makes it hard to adjust the brakes properly.
You can fix either of these conditions by changing the clearance between the shoe web and the cam pin. The dope on how to do it is in the reference book.
Now, here's a piece of lining we replaced in a taxi cab. See how the lining is worn in the center? This is caused by applying the pedal repeatedly on hard stops. You see, on extremely heavy brake applications, the pressure from the wheel cylinder springs the shoe just enough so that the center of the lining contacts the drum the hardest. Naturally, the lining wears into a dish-shaped cross-section with the center of the lining low and the edges high. The next time the brakes are applied lightly, the edges contact the drum first and cause noise. You can sometimes correct this by relieving the edges with a grinder.
Another way of getting brake noises is from loose linings. But if you use a clamp when you put the lining on, you'll get it tight, and it won't buckle or bulge up on you, causing vibration and noise.
Well, let's get down to work and pull these shoes. First, we've got to back off the cams to avoid overstretching the springs and remove the return springs from the shoes.
And don't use a pair of side cutters. You're liable to damage the spring.
Right, Tech. And then we'll drive out the anchor bolt washers. And when you remove the shoe, slide it out from under the guide spring carefully so you don't bend the spring. This is the time to check the anchor bolt holes for clearance, George. If the shoes are too loose on the anchor, you'll get noise, so you'll have to replace them. Now we're going to use cycle bond linings on this job, so...
Say, what is this cycle bond process? Why do we use it?
Cycle bonding is a new process, George. It means cementing the linings to the shoe under heat and pressure in a special oven. It's practically like welding the linings on. Here are some things to remember, George, in order to get a good cycle bonding job. The date stamped on the MyMopar package is very important. If that date is passed, you've got to apply new cement before you use that lining. And all dirt and grease must be removed from the shoes with cleaning solvent.
And after you remove the old linings, the shoes must be sanded down to a clean, bright metal bonding surface. This means sanding all the plating off so you have a clean steel surface.
Then the new lining must be held to the shoe with a special clamp so the lining will stretch out evenly along the shoe.
This special clamp gives the necessary pressure for curing.
Well, what is this curing?
The shoes must be cured or bonded in an oven, and the timing and temperature are very important.
Look up the timing and temperature in this instruction book every time, George, and you'll always cure them just enough and no more.
Now, there are two reasons why we're cycle bonding these linings instead of riveting them on. First, you get longer wear because you can wear cycle bonded linings almost down to the shoes before relining.
Yes, you see, with riveted linings, you're caught up as soon as the linings get worn down to the rivet heads.
And second, in cycle bonding, you don't have rivet holes for the dirt to pile up in, so your drums can't get scored as easily. Now let's take a look at the brake drums. These aren't badly scored, and we can give them a rub down with emery cloth to clean up the scratches and high spots. Then, with the drum gauge, we'll check them for being out of round. If the drums are badly out of round, they'll cause changing pressure against the shoes. The driver will feel a pumping action at the brake pedal. In that case, you got to resurface the drums in a lathe or install new ones. Another reason for resurfacing the drums is when the score marks are more than about 10 thousandths deep. Scores this deep would cut the new lining.
And remember, George, never cut more than 30 thousandths. You see, taking out 30 thousandths all around increases the drum diameter 60 thousandths.
That's right, Tech. If you take more, the drum will be too thin for satisfactory operation.
By the way, fellas, there's a 30 thousandths thicker lining available for use with drums that have been turned.
Right, Tech. Now, before you install the shoes, check them on a surface plate or some other flat surface to be sure the shoes are true. You can use your connecting rod or lining fixture for this.
What about grinding the linings to make them true?
You can grind linings to true them up after you've screwed up a cocked shoe. It doesn't do a bit of good to try to correct brake noise by grinding without first truing up the shoe.
Right, Wally. And when you're grinding new linings, here's a suggestion. Grind the linings 20 thousandths under the drum diameter, and your new linings will wear in better.
That's a good idea. It'll prevent heavy heel and toe contact that could give you squeaking. Now, when you're ready to install the shoes, you apply a light coating of lubriplate to the push rod pins, return spring holes, and the shoe web under the guide springs. That'll prevent noise caused by dryness.
Don't forget to put a light coating of lubriplate on the anchors and the adjusting cams, too. And don't use anything but lubriplate, George.
Lubriplate resists heat. It doesn't thin out and drip on the linings unless you use too much. Just a little is all you need. Now, we'll compare the return springs with the new ones to make sure the tension is right. and install them. Next, we'll set the drum gauge to the inside diameter of the drum. This measurement automatically gives us our 6/1000 clearance for this drum. We now can set the shoe gauge by matching it to the drum gauge. We mount the shoe gauge on the spindle and bring the toe up against the gauge finger by turning the cam pin adjustment at the back of the support plate. Then, adjust the anchor bolt until the heel of the shoe has the proper clearance.
The arrow on the anchor bolt must always point away from the heel of the shoe. If it's installed with the arrow towards the shoe, it may lock the brake if it loosens up.
Right, Tech. And to increase the clearance, turn the arrow slightly away from the drum. To decrease the clearance, turn the arrow slightly toward the drum. Next, tighten the anchor bolt nuts from between 55 to 75-pound tension with a torque wrench, and lock the lower ones on the front wheels with cotter pins. Then we'll finish up the rest of the wheels.
Looks like the job is pretty well licked, Wally.
We'll give it the road test as soon as we're through adjusting the wheel bearings, Dave. Are you satisfied now, Tech?
I am, because I know the customer will be. Fellas, you should never forget, the customer's confidence in you and in your organization is only as good as his confidence in your workmanship. Not only that, when it comes to fixing brakes, like I said before, somebody's life depends on you.